about to start the next session. So Araceli, if you can stop the music, and yeah, very good. So yeah, we're about to start the final session of today's conference. So I'd like to give the floor to our moderator now, Tigran.
Hello, everybody. I hope you can hear me.
Yeah, I can
Thank
hear
you
you.
very much for this opportunity to moderate this very interesting session on financing. I would like to introduce our panelists, if possible. From Fraunhofer, Ms. Teda Sochke, who is a technical expert in high-temperature solar, thermal, and industrial processes. Then we have from Kyoto, Remy Cuer, who is an investment specialist. And then from Ernst & Young, we have Alexis Katsov, who is a partner at Ernst & Young. But I would like to give the floor to a panelists and also allow them to introduce themselves maybe better, and then we'll get to the presentations. Thank you. Teda, would you like to start?
Yes, I can start. Yeah, so thanks to the World Bank for the invitation to this event. My name is Teda Sochke, as you already mentioned. I'm with the Fraunhofer Institute for Solar Energy Systems in Freiburg, Germany. We are the largest research on solar technologies in Europe, with working in many different business areas like photovoltaics, energy efficient buildings, also related technologies like hydrogen technologies, but also solar thermal, and this is where I'm working, focusing on technical dynamic system simulations, but also performing techno-economic analysis, and this is why I'm in the session today. And yeah, I'm happy to share the results that we did for the MENA-KIP project in Tunisia.
So following Remy Cuer from Firm, which is a third-party investor in renewable heat projects, and notably also solar thermal ones, both flat plates and concentrated solar thermal. And I'm here to present the ESCO third-party financing mechanism for concentrated solar thermal projects.
Hi, I'm Alexis Gazo. I'm a partner at EY. I work in a team which specializes on energy transition and climate change. EY has been the lead consultant for the MENA CSP KIP program, which is basically organizing this event with our partners, ATA, Fraunhofer, and so forth. So I've been coordinating this program for the last 3 years, and I'll speak a bit later on about what we did on CSH, and in particular on the small grant program that we initiated in Morocco. Thanks.
Thank you very much for the introductions. I forgot to introduce myself. I'm an energy specialist with the World Bank, with the ESMAP. So great, then I would like to give the floor to Teda to start the presentations.
Okay.
Teda, thank you.
Yes, thank you. Okay, so again, welcome from my side. I will start with my presentation on the techno-economic analysis for CSH plant in Tunisia. I will introduce quickly how we perform at Fraunhofer ISE feasibility studies, and then I will show 2 case studies that we did in Tunisia. And how we performed the techno-economic analysis, and finally the conclusions that we could draw from them. So basically the procedure for feasibility studies is like this. We start with a company visit, collecting data on the company, but also on the different processes. Then we analyze this data and we find good assumptions for the missing data, and we identify energy efficiency measures, because it's always important to prioritize energy efficiency measures over the integration of solar thermal. Then we derive the so-called effective energy demand, and from this we can select system layout and components. And then with our own in-house tool, we perform dynamic system simulations, taking into consideration transient effects as well, and yeah, try to get an energy yield for the specific site and the process. And then with this data, we perform finally the techno-economic assessments and also do a design optimization. I will show this later. And from this, we can yeah, draw recommendations and make decisions for the customer or with the customer. And yeah, we are focusing here on parabolic trough collector, linear Fresnel collector for concentrating solar heat, so specifically for steam generation. This was being looked at in Tunisia. And yeah, we had these two companies here. It was one dairy plant in the center of Tunisia and one textile plant in the north of Tunisia. The technical parameters were actually quite similar, so an annual energy consumption of 20 and 24 gigawatt hours, and 50% of this energy consumption was used for thermal processes. And the steam temperature is 170 degrees, the steam pressure 8 bar. And then in the schedule, there's a small difference. So in the dairy plant, we had a 7-day per week operation. In the textile plant, we have a 6-day per week operation, and we will actually see later that this also affects the results. And also a big difference is the current energy source and the energy price. So in the case of the dairy plant, we have 4.5 euro cents per kilowatt hour. And in the textile company, we just have 2.5 euro cents per kilowatt hour, which is very tough to compete with solar thermal systems. On the right-hand side, you can see a map of the DNI data in all of Tunisia, and you can see that the values are quite good. So in average, we have 2,000 kilowatt hours per square meters. So you can say that all this gives quite suitable conditions for concentrating solar process heat. Yeah, so for these two companies, we performed these technical simulation studies. For this, we looked at different solar field sizes and also different storage sizes. And yeah, we did these simulations, and finally we evaluated them in the economic analysis, considering different financial parameters and calculating financial KPIs, like for example, the payback time, like you can see on the right-hand side. So we considered a lifetime of 20 years, solar field cost of 450 euros per square meter, a discount rate of 8%. And then, and this was special to this study, we varied the amount of incentives from about 20% to 80%. So we had a lot of different scenarios for the different companies and the different incentive programs, and created analysis, like a design optimization for this. And this is what you can see on the right-hand side. On the x-axis is the solar field area in square meter, on the y-axis the payback time. And the different colored lines are the different storage sizes that were considered. And with this, we could easily see in this graph what the ideal system dimension is in order to get a good payback period. And this is what we did now for both companies for different scenarios of incentives. And yeah, this created a lot of different plots, and I will spare you now looking at all of the different plots. I will just show you the results of this study. So yeah, you can see on this graph here, on the x-axis, the incentives, on the capex in percent, and on the y-axis, the related payback time in years. So we can start with the blue line, company 2. It shows that the discounted payback time varies from 10 to 18 years. So this is quite high, and it actually also shows that without any incentives, the project would not be feasible. So if you extrapolate this line to incentives of 0%, you will see that the payback time exceeds 20 years. the case of company one is already much better. So we can see here with these incentives that we assumed we reach discounted payback times of 5 to 10 years, which is already much better. And the difference between these lines definitely comes from what I said earlier. So this is mainly the current heat generation cost that was much higher for company two, and also that the schedule is different. So we see for company two that it's just a 6-day per week operation, and this immediately has an impact on the payback period as well. I want to really point out that this is, of course, no general answer to CSH in Tunisia. So this is just pointing at 2 cases that we looked at, and it highly depends on different technical and financial boundaries that are always different. And we all know that CSH is a case-by-case decision making. But yeah, so we still see that incentives can be very important to bring CSH into the market. And we also all know that the payback time is maybe not the best KPI to make decisions, to rather look at IRR or NPV. But still, we know from experience that payback time is the KPI that companies look at to make their decisions. And usually they expect quite low payback times, below 5, maybe below 3 years. And I think, why is this? Because I think that planning ahead is much more difficult for these companies focusing on their products. They have fuel cost variations in their process parameters, and in the end, it is a KPI that gives an indication on the risk of an assessment. And this is also very important, and it's important to implement incentive schemes that can reduce this for the customer. Okay, so there are some technical levers to reduce the payback time. First, it is good to find companies and processes that already have quite high conventional energy costs. So maybe have rather old boilers, diesel boilers, maybe some with lower efficiency. So that definitely helps for the economic assessment. Secondly, and especially for steam generating processes, it is important to have continuous and reliable processes with possibly 7 days per week operation, because you can imagine comparing this to a 5-day per week operation is already 20% less yield in the end of the year, so this has a big impact as well. Then the system dimensioning also has an influence. So we heard already in the session before the difference between integration at supply and process level. If we talk about steam generation with concentrating systems, we usually talk about integration at supply level. And here it's usually best to aim for solar fractions below 30%, so no storage is needed, which reduces the complexity of the system and therefore also reduces the payback time. And then the thermal heat can immediately be consumed by the processes. Okay, yeah, so finally, Tunisia shows very suitable conditions for CSH. We see that projects are definitely possible and feasible. The payback times can also be low, especially if we consider high incentives. Yet they are often not low enough for industrial companies to really take decisions. And yeah, financial mechanisms are important to resolve the remaining risks for the company. So this can be ESCO models. I think we will hear more about this later. Also funds that are maybe also specific to solar thermal technologies. Then we can reduce the project evaluation costs, or also create funds and programs that take over this effort. Yeah, we can implement the incentive schemes as said, and the idea behind all of this is in the end to create also a larger market volume and therefore bring down the cost of CSH, and this will also of course reduce then the decision-making process, or improve the decision-making process for the companies. Thank you.
Thank you very much, Teda. for a very interesting presentation. I would like next to give the floor to Alexis, and then please, for all the participants, we will go into the Q&A session after all the presentations are made. Thank you very much. Alexis, the floor is yours.
Okay, I will share my screen. Right, I hope you do see my screen. I will say a few words about the way the MENA CSP KIP program captured the CSH opportunities in the MENA region. I won't go through some of these slides, which are basically just a presentation of CSH technologies. One thing, and I think some of these slides have also been shared earlier on in the sessions focused on Morocco, because one of our focuses was Morocco. But basically, I think in this slide, it's interesting to see that, based on IRENA's data, if you take the industry energy demand, which is basically 1/3 of energy demand, well, a big chunk of that is actually heat. And when I say big chunk, it's nearly 3/4. And within this heat demand, a lot is actually low temperature heat or medium temperature heat. Basically, some of the needs that can be addressed by CSH. So that was one of the items that were one of the driving axes in our analysis. I think what we did during the MENA CSP KIP program was to work with the countries, and I think that I explained quite well the work that had been in Tunisia. The idea was to look at a number of industry sectors, whether food, paper, textile, etc., based on the industry landscape of each country, to see where we could identify processes with heat needs that were compatible with CSH. So this was done in several countries, and again, I think that gave a good example with Tunisia. Here is another example, which is more focused on Morocco, based on a countrywide analysis that we did, where we looked at a number of priority sectors, including, for instance, the food industry, the automotive industry, chemicals as well, pulp and paper. I'm giving them in a mixed order, where we identified the temperature requirements for heat processes, and then to look at what kind of CSH technologies were most adapted, whether linear Fresnel or parabolic trough, and so forth. So again, this was an analysis that has been done in several countries. Again, Theda presented Tunisia, this is Morocco, but this was done also in Palestine and some other places. I think here it's simply another example, still in Morocco, on the heat and temperature requirements sector by sector. And again, I won't go much in details. I'm keeping this pretty short, knowing that all the slides will be available afterwards. But you can see that again, so some needs are quite actually for rather low temperatures. Others are more in the range of 90 to 250 degrees. Others are higher. It's a pretty mixed picture, really, but showing that there are requirements that can be adapted to different kinds of technology approaches. Here are two existing projects which have been operating for a while in Morocco. One is a COPAG, and it's a rooftop installation, which is pretty much a small scale one. And the other one is a project which is a bit larger, that has been applied to a cement factory in Morocco. If we switch to another country, I wanted to mention that we conducted a number of feasibility analysis in Palestine, and I was again with our colleagues from Fraunhofer Institute, by the way. We looked at different industrial plants, commercial and industrial plants, sorry, and one was in particular with a hospital in Ramallah. I think, again, I'm trying to extract some of the key findings from the feasibility analysis, but if you want to perhaps picture a few items, based on our analysis, we identified an investment cost which was a bit below $100,000 with an IRR of 35% and a payback time of a bit below 3 years. So that's just to give you some indications on the type of projects that we have looked at and the type of key figures that came out of these analysis. This means that for this type of project, beyond the economic incentive, where we consider that 45% of the fuel consumption could be saved, and that's basically over 100,000 liters of diesel savings each year. This also means that you get significant CO2 emission reduction, that you get also reduction of SOx, NOx, but you also contribute to local economic development, maybe on a small scale, but still, it's creating jobs and revenue for suppliers in the supply chain. Although there are some number of projects that exist, and I think again we've had examples earlier on Jordan as well. There are a number of barriers that face deployment of these projects. I think a major obstacle that we've encountered is the question of awareness over CSH technologies and their performance. There's not a lot of key projects that can provide examples of success stories and basically inspiration for a number of industrial and commercial customers. As you know, in the region, many companies are rather small companies. There's a lot of SMEs. It's a rather fragmented sector, the industry sector in most of the MENA countries. And for that reason, I think the level of investments is always quite critical. So we have looked at rather small investments possible, but even for investments in the range of $100,000, it can be quite a major step for the CEO of a company. So there's really a barrier in the fact of presenting a project that is a small capex, that has a very good IRR and a small payback period, but still, the CEO of the company will be very complicated to convince. He will need guarantees on the performance of the system, on on the choice of allocating capital rather to improving his marketing or other aspects. Whereas dealing with energy processes is not something that they master. They don't necessarily have an energy specialist, and so there's a lot of I think problems around convincing the CEO to make the decision, to put it very simply. So for that reason, we understood that having a grant component could be useful on one hand to support feasibility analysis, and some were financed by the program in different countries, but also an investment grant component, and that's what we did with the small grant program. And I'll say a few words about that right now. Yeah, perhaps before I mention the small grant program very quickly, just want to say that the reason why we went ahead for that was to say that CSH has many advantages. It's obviously something that can really play a role in the energy independence of a country, applied again to the industry sector. It's providing the consumer, the industrial consumer, with better visibility on energy cost, better adaptability to the energy needs, etc. There is obviously a local economic development component, because this can support local jobs, this can support a number of local suppliers, and obviously this is going to grow the capacities in terms of expertise in renewable energy that can be deployed also to other sectors. Now, on the small grant, as you understand, we deployed this small grant in Morocco. So I think the solar cluster has already mentioned this earlier, so I'll be quick. But basically, we have set up a program which was in a call for project mode in partnership with the Cluster Solaire in Morocco. So we reached out to a number of industrial companies saying that we were targeting industrial or commercial companies. So the need was to have a 50% ownership locally. So that's to target really local companies with a number of possibilities also to include as partners engineering firms, experts, developers of technologies, and so on. We focused on projects which were basically rather small capacity for demonstration purposes in an industrial context with thermal or electrical applications and without any restrictions in terms of CSH technologies. And we had, we were targeting projects with initially, rather around basically maximum $500,000 of capex, just as an estimate. Obviously, this was an indication, but that was how we built the call for projects. And in the end, we supported a project to produce bitumen. And again, I think that's been mentioned a bit earlier. We had the one of the partners of the project speaking as well. So this project is being launched, which is a good thing. We had other discussions which were very advanced in the textile sector, but unfortunately, again, since we were expecting for a participation also by the industrial company, in these cases, it took too long to get the sign-off from the industrial partner, and that's again one of the barriers that we're facing in this market. And so just to finish, I think I'd just like to mention that we think CSH can be very attractive. I mean, it can be very attractive from a financial perspective. Again, there's a lot of energy savings to be brought. Projects can have very good IRRs, and it's a very good hedge against possible evolutions and fluctuations of fuel prices. It has also obviously some strong environmental benefits, not only greenhouse gas in general, but also on local air pollution, which, as you know, is quite an issue in a number of cities in emerging markets. And it's also pushing the development of small scale or medium scale renewable energy development. And last but not least, there's also, and we really think it's important to mention this as well, industrial and economic benefits as well, because a number of components can be manufactured locally and can fit quite well with all the metallic component industry that exists in most of the countries that we've worked with, as well as the electrical component industry. So we really think that there's a trio of strong benefits. The thing is, we need to have, I think, key success stories that we can build on to better promote this type of projects. That's it for me. Thank you.
Thank you very much, Alexis. With this, I would like to give the floor to Remy.
Thank you, Tigran. So as a transition, so Fida and Alexis clearly explained that there are a lot of very relevant projects in the concentrated solar thermal industry, but often one of the main issue, and I'm going to open my presentation. Just Tigran, to share my presentation, do I need to do something specially, or?
There is a share screen button at the bottom, the green one.
Yes. Okay.
Right, you've got it, Tigran.
So as they both explained, financing can often be a huge issue for the development of these projects. And the solution we want to push forward at Firm is proposing solar thermal energy, and notably concentrated solar thermal energy, as a service, as an escrow service to industrial users. what I guess a lot of people in the industry have heard of is that when they propose a relevant project to industry users, they often get the answers that, well, it's very interesting, but payback is higher than 18 or 24 months, and I cannot invest and I cannot validate the project. So that's a huge issue. Whereas if you come to the industry user and tell him, I will take care of the investment and sell you the energy per kilowatt hour, this can really help implement the project. And that's because, well, concentrated solar thermal energy, as a lot of other renewable energy, is a very capital intensive industry and projects. And this is understandable that industry users, which have also to invest in their core business, would rather prioritize their core business. And one important issue that has to be taken into account also is that industry users, for example, in the dairy industry or textile industries, they may have a lot of very good engineers and technicians, but they are not used to analyzing concentrated solar thermal projects, and they can also be kind of stress at investing in a very capital industry intensive project and not being able to really assess the efficiency of that project. So for all these reasons, we really think that selling solar thermal energy as a service on an ESCO basis, practically said in dollars per kilowatt hour, can really be a big help to develop the industry. One other really important topic that has to be brought forward is that it is, of course, very good if you come to an industrial client and tell him, I will take care of the investment and sell you the energy, but you also have to have a competitive cost of energy, because if you come to, let's say, a dairy site and tell him, I will sell you solar thermal energy, but it will cost twice as much as what you're already paying for your energy, then of course everybody understand this will not be a big success. And what we want to stress is that to really help have a competitive cost of solar thermal energy, one important issue is to really optimize the cost of financing. I think one very good example everybody has in mind is the PV industry. PV at its beginning was very costly. You had price which were feed-in tariffs which were at 500 euros per megawatt hours. And what has really helped PV become cost effective is optimizing every cost, and financing has been one of them. And now when you look at the PV industry, financing is kind of a commodity. It's very cost effective. And what we intend to do at Skyfirm is apply the same for solar thermal industry, meaning having a very optimized cost of capital to lower the cost of energy and implement as many projects as possible. But in order to do that, you need to have a very good understanding of each project's risk and being able to allocate the different risks of a project to the different stakeholders of this project. So this is what we typically do at Skyfirm, which is an investment company specialized in renewable heat projects. So it was funded in 2011, and at the beginning we were mostly investing in geothermal biomass district heating projects, and lately have had a closer look at solar thermal projects, which we think is a very interesting industry and which can really develop on a worldwide basis. So we typically invest in projects that can be in size around 10, 20 million dollars. But we know that a lot of solar thermal projects are kind of a small size. So we can go down up to $500,000 in terms of project size. Even though from our experience, in order to have ESCO projects which are cost competitive, it's better if they are a little bit bigger than this. Regarding solar thermal projects, we are based in France, in Paris, but we have a worldwide approach. We really want to finance projects all around the globe, and of course look at the geographies where you have the most sun. And what's also to stress is that we have our own institutional investors, so we finance projects ourselves. We're not an advisory company. And so all of this is to able to team up with any project developers in the concentrated solar thermal industry that have a project, that have a client which thinks the project is relevant, but the project is not going forward because of financing issues. So ourselves at Firm, we are not a collector manufacturer, we are not an EPC contractor or O&M operator. We really are just focusing on the financing aspects and teaming up with developers in order for projects to really get implemented. So on the presentation, you can see typical risk metrics for concentrated solar thermal projects. So on the left, you have the main risk you can encounter on these projects. So for example, the risk that your client closes down the factory, the O&M or EPC risk. And you have on the risk metrics how we usually can deal with these kinds of projects. So, well, in a nutshell, of course, the investor, Firm as an investor, will in all cases bear the risk of the creditworthiness of a client, the risk that a client can close down its plants, as well as the solar irradiance plants. And then all the other risks are shared or taken by other stakeholders. So being the EPC contractor, O&M operator, and the heat user. And of course, it makes sense, but the less risk we have on the project, the better the price or the cost of capital can be on each project. But that's really an evaluation that we do on a project by project basis. And so to illustrate what we are doing, so sadly we are in discussions on concentrated solar thermal projects, but I've not signed one yet, so I couldn't present one to you today. But I could present you one project we have financed, which is with flat plate collectors, which is a 14.2 thousand square meters project for a melting plant, which is currently being built in France, which we have financed and which is roughly 6 million euros. And so what's interesting to see is that we really tried to have the most optimized cost of financing so that this could be of interest to the clients. So we finance it with a roughly 5% project IRR. And what's also interesting is that we have a 20-year contract, so which really allows to decrease the cost of energy. And so meaning that we also take, Firm, the risk that these plants may close down before the 20 years. But that was really important in driving down the cost of energy. And we've also worked with the bank at the latest stage, but we have financed 100% of a project with equity as of the construction start. And so thank you very much. That's it for me.
Thank you very much, Remy. With this, I would like to go to the questions, to the Q&A session. We have received a couple of questions online. There are some questions that I would like to ask as well. I think we'll start with the ones that we have received from the audience. But before that, I'd like to briefly tell you about the industrial decarbonization program that the World Bank is currently running, and it is with us, with the ESMA. We started the program this year. We launched this industrial decarbonization program, which is integrating the current work streams into a program focused on technological innovation and piloting in the World Bank Group client countries. The program will be supporting both the global knowledge as well as providing country grants for market assessments, support to enabling environments, pre-feasibility studies, supporting to piloting of innovative technologies that could be assessed both by the World Bank as well as in partnership with the International Finance Corporation, the IFC. So yes, with this, I would like to go to the questions. So there is one question from the audience asking how do the World Bank and other multilateral development organizations and the banks going to use the industrial decarbonization program of the CTF to develop large-scale concentrated solar heat projects? I'd like to answer to this one from our perspective. The industrial decarbonization program has just started. We're trying to roll it out. We have already received a couple of project ideas from the regions, and we're considering those. The concentrated solar will be one of the areas that the program will be looking at. But there will be many more areas because this involves a larger umbrella of potential projects and technologies. But yeah, I mean, of course, the CSH is one of the greatest areas, and the heat is one of the biggest issues in the industrial decarbonization program. So we will be looking at that greatly. If anyone wants to answer this in more details or any other additions, please. There are some questions. I'm sorry. There's another question from the audience asking, and this is for all the panelists. All the examples are pretty small scale. Has any of the panel members looked at larger scale projects, like over 20 megawatt opportunities? If so, what stands between where projects are now and these larger scale potentials? Who would like to take
Maybe
panelists?
I'll start just to kick off the discussion. Yeah, I think on our side, within the program, it was a deliberate choice to try to focus on more small-scale projects, because we had the feeling that whilst a number of large companies, whether in the cement industry, in the phosphate industry, or others, had already a number of, I mean, basically, you know, energy-intensive users at a large scale had already a number of energy efficiency projects at large, or renewable energy projects to work on how to optimize their energy consumption. However, again, in the countries that we are talking of, the industry sector is very fragmented, and so you have, you know, 90% or 95% of the companies which are in fact small companies, small industries, and these companies don't necessarily have the information about the opportunities of using renewable energy, and in particular CSH, and they don't always have also the internal capacity to work on these projects, to have feasibility studies, etc. So, you know, for that reason, we thought it made sense. And again, it's really the idea of disseminating in a very broad panel of industries, which are rather small industries. So, you know, it was a deliberate choice. And for this reason, we didn't really look at these large opportunities. So it's hard for me to answer to the question of why such projects don't necessarily come out of the ground. Maybe I'll leave it to my other colleagues to complete the answer.
Yes, on my side, we do see larger projects, and we think, well, in a lot of cases, having larger projects helps having more competitive ones. Well, we haven't seen to date a lot of projects that are above 20 megawatts. It's huge. We have seen some, but not a lot. But we are studying some which are rather around 10 megawatts.
Yeah, I also wanted to mention that, of course, it's often a question of space as well. So if we talk about companies, and these very large systems require huge aperture areas, and especially for companies that are more in urban areas, this is usually, the space is not available.
Thank you very much for all the answers. There's another interesting question from the audience, which is asking, what can concentrated solar heat technologies contribute to decarbonize most of the industrial sectors in Morocco? I think that refers to other countries as well, but it's a particular question. I'd like the panelists to take it and to express the views.
Well, maybe, I mean, quickly, and you know, maybe also Theda can complete also on Tunisia. It's another country, but I think the context is pretty much the same. I mean, the quick answer is yes. I mean, as we've seen, the needs in terms of temperature for industrial processes are quite varied, and they're quite present amongst many sectors. So, you know, what we've seen is that for a lot of industries, it makes sense. The question is afterwards, you know, when you're within these industry sectors, what's the right, I would say, what's the right context for setting up a given project? What I mean by that is in some cases, you will need to find the right company which has the bandwidth to implement the project, which has the right timing because they are planning an extension of their factory or to build a new factory, or they have some revamping to do. I mean, there's a number of factors that are going to help the way in which to prioritize project. But overall, yes, I mean, we think it's a solution that can be applicable to many different sectors, in particular in Morocco, but it's, you know, pretty much the same case, I think, in neighboring countries.
Yes, I also think that it definitely can contribute to the decarbonization, also in Morocco and all of the MENA region, of course. And especially if we speak about these high temperature systems and steam generation, I also don't think there's so much more renewable energies that can provide this and cover actually provide this heat. So mostly when we speak about renewable energies, we are talking about electricity, but yeah, maybe there's biomass, boilers, but also there's not so many competitive technologies in this range.
Thank you very much. There's another question which is very actual, but I don't know how relevant we can be on that. Do you think that COVID-19 crisis will foster the financing of concentrated solar heat projects, particularly in less developed countries? Anybody has any view on this?
I'm not sure to fully understand the question. At least, of course, it's not very helpful this month, both for the development of projects and for projects which are under construction. So I don't see how it could help the financing. What we see is rather the current low cost of energy, which is an issue for projects and which could foster the ESCO developments.
I don't know if the question was a question of fostering the needs for energy independence and in that way for such projects. But myself, I wasn't really sure about the question. Perhaps going back to you, Rémi, maybe a complementary question on my side, if Tigran allows. How do you see the current, you know, crisis affecting financing costs? I mean, obviously, I'm talking more in a prospective way. But do you feel? I mean, it was interesting to see your point about saying, well, 1% of financing costs equals 10% of more capex of 100 more percent OPEX. How do you see financing conditions in the next months?
Well, there's of course higher risk premium due to higher likelihood of insolvencies. So this will of course impact the overall cost of financing.
Okay, thank you. I have another question, which is, I think, for the more larger audience and the more larger country coverage. Are there any, and what are the requirements to deploy the concentrated solar heat with commercial and industrial clients in MENA, if there are any requirements like that? Maybe Alexis will take that.
Yeah, at least I can try. But again, I think my colleagues will be able to usefully complete. Well, you know, I think there's a number of technical requirements on one hand, which will be related obviously to irradiation conditions, which are usually pretty good, which will be related to availability of sufficient surface, either on the ground or on the roof. So depending on the configuration of the industry, and obviously it relates to the industrial process themselves and how you can better adapt to these needs in terms of heat and or power. The other, I think, requirements are non-technical, and again, they go back to the capacity of the commercial or industrial company, except obviously if there's a third-party ESCO type of player. But if it's not the case, you're going to need to have a company which is able to have sufficient capacity in terms of managing technical projects, energy projects, and basically having sufficiently, I think, understanding of what it means on the long term. Because when a company engages in such project, it's for in the idea to gain money after a certain number of years. The payback can be short, but still a few years before you get results. And these results will lie quite a lot in the way in which the project is operated. You have a number of operating risks that you have to be able to master. So, I think it's also pretty related to how the company can dedicate a person with sufficient technical and economic skills to control the project. And it's not always available when it's an SME, obviously, as you can understand. And then obviously, but I think, Rémi can also say a word, obviously the financing conditions, which are pretty key, as we have seen in the economic balance of the project.
Rémi, would you like to comment on this?
Sorry, just what was the question specifically on the MENA region? Tigran?
No. The question was, yes, I mean, it was on the MENA, but what are the general requirements to deploy the CSH with commercial and industrial clients? I mean, it is referring to MENA region, of course, but you can elaborate more if you'd like.
Well, I think as Alexis has said, the operation then of a project is key, and it's also the success of a project will really depend on how well you've understood the client's process. Everybody knows that for example, the temperatures at which the client operates are very key, for example. So I would say what's key for a project is having a very good understanding of a client's process and how it will also evolve through time. And so that's something that every investor in the project does, and that's what we do. And I would say for a commercial aspect, when you sell energy per kilowatt hour or gigajoule, this means that the investor really takes the performance risk, and the client doesn't have to take this risk. And for example, if you have Alexis was telling about SME, which doesn't necessarily have someone that can be in charge of following this project. This can be a very, I would say, a very good factor for them to decide for the implementation of the project. The fact that they will not be bearing this performance risk.
Thank you, Rémi. There is another question, which is a rather interesting one. What is the price premium that end users pay to have the heat as a service? So, I mean, it refers to also the whole concept of having heat as a service, which is an interesting one. Anybody would like to take this?
Well, of course, when you have a third party which is going to finance a project, it will have its own cost of financing and expecting financial returns. And some people see this as an extra cost, but I think it's an error, because you have to compare the cost of financing of this third party to the cost of financing of the end user. And so if the third party which finances the project has a lower cost of financing, well, it's not an extra cost, it's actually a saving they do. And a lot of industrial companies, they have what is called WACC, which is the key data which follows how much the internal cost of financing is. we have often the WACC figures that are very high, which can be practically a double digit. And when we finance solar thermal projects with a 5 or 6% cost of financing, but it's not an extra cost, it's rather a saving.
Anybody would like to add? Okay. Another question that I'd like to ask all the panelists, because this refers to everybody, I think. What are the good arguments to convince companies to implement solar thermal systems, despite all the issues that were just listed? Like, how would you convince the company to go for it? Maybe Teda can take it, or Alexis, whoever.
But yeah, I can start. Yeah, of course, I think it's always a good investment in the future, of course, contributing to environmental goals and contributing to climate change. And also, I think it helps to gain independence of the volatility of the fossil fuel price. So in the end, I think we also heard this before in the previous sessions. That the price of solar systems can actually be estimated quite accurately compared to conventional fuel prices. And then, of course, it can also be used for marketing purposes. So, yeah, because I think it's well noted if companies invest in environmental projects, and especially interesting, I think this is for companies that have a product that is directly sold to a customer, so no distributors of people in between, because I think there it really comes down to the cost in the end, or the cost of the product. But for example, in the case of the dairy, I think is a very good example, because they are directly selling their milk and yogurt to the client, and I think it can be really help to improve the selling. Yes.
Thank you. So, Alexis, what you would like to add?
Yeah, I mean, Seda, I think, said the most important points. Obviously, I think the key arguments are around the economics and the fact that you're really providing energy savings and potentially a project that can be quite a good financial investment on the long run. But beyond that, it's providing the industrial company with a better control over its energy supply. And again, it's a question of independence in a way, and protection, hedge against the volatility of future energy prices. I think it's a good point also what Seda said about the image aspect to it, because a number of companies in the MENA region are exporting quite a lot to European markets, and more they have requirements from their European buyers of having very high standards in terms of environmental performance. So this is also a way to I think stay amongst the key suppliers for some of their clients beyond the general image and brand aspect. And then obviously I think it's also a way again to promote the development of local supply chains around these technologies, which can foster more jobs, as we have said, which is, I think, is also an important point. So yeah, I think these would be the main messages.
Thank you very much. I'm not sure. Are we supposed to end the session now, according to the schedule, or shall we continue with some questions?
I think you can answer one more question, the bonus question.
Okay, cool.
And then that's it.
So then I'll have another question. In addition to the optimized cost, and this is for Remy, of financing, what could allow the concentrated solar thermal to become more competitive?
I think one big issue we have is volumes. We need more projects. I was referring to the PV industry before that, but what has really allowed the PV industry to have efficient cost is volumes, because what's better financing, but it's also lower installation cost. it's factories doing panels, which has fixed costs divided by much higher volumes. So I think that's really a key issue for the industry implementing more projects. So on our side, we are trying to finance them with optimized cost of capital to have more projects. And that's really the big idea here.
Thank you, Remy. Alexis, Dada, would you like to add on this anything? Okay. Then with this, I think we'll conclude the session. Carlos, Anna, would you like to say something, or anybody would like to say some final words?
Well, Tigran, thank you very much, and thank you to all the panelists and the audience who have stuck with us until the end. I believe that probably Jonathan would like to say some closing remarks. Am I right, Jonathan?
Sure. Always happy for a chance to speak. Right now, thank you very much to the panelists for this session and the 3 previous ones. Thank you to Tigran and to the other moderators. Carlos, you are the face of the ATA team, but there are a number of other heroes behind you as well. So thank you very much for making this happen. And thank you most of all to the participants. This is for you, and your feedback on how this worked for you is essential. This is an experiment for us, so we're trying to see whether this format can be successful in carrying on our knowledge exchange work under current conditions. My impression sitting here is that it's worked rather well, but we do need your feedback to help us decide whether to carry forward with this kind of format. My overall takeaways from today are that concentrating solar heat, it's a strategic area. It's complex. There are many players. It's a retail sort of business, but the challenges are familiar to those of us who've worked in energy efficiency for many years. But the potential is great. This will be, as Tigran mentioned, an area of growth for us in the World Bank. So we look forward to continuing to work with all of you going forward. The MENA CSP Knowledge and Innovation Program will be winding down, but the work that has begun with this will be carried forward by other programs of the bank. So Tigran, I'm looking at you. But we'll be back. Remy, Theda, Alexi, thank you again, and see you all again soon. Bye.